So this is my project on buoyancy. Essentially, so before we have to get into it, we have to know what Archimedes' principle is, and we have to know what buoyant force is. So the buoyant force is equal to the force of the object over the area. Now the force of the object in this case is going to be the weight mg, and we can see how the buoyant force interacts with the object with these arrows and this big dot. The buoyant force is the upward force exerted by the fluid that opposes the weight of the object. Now, we want to know how buoyancy really works. We can see here PF and PO, density of fluid and density of the object. If PF is greater than PO, it'll float. If PF is equal to PO, it won't move in the water or fluid. And if PF is less than PO, it'll sink. So I have three objects here, wood, steel, and ice. And the wood here in this case is going to be the least dense, the steel is going to be the most dense, and the ice is going to be in between. And we can actually see how these objects interact with the fluid. Now this is just basic water, so 1,000 kilograms per meter squared, and this is pretty expected. So let me just pause it here. The steel has displaced the most water, ice second, and wood third. Also, the wood is partially submerged. Ice does get completely submerged, and the steel is probably never coming up. So that brings up a good point. How did steel displace more water than wood, So, according to Archimedes' principle, the amount of water displaced is equal to the weight of the water displaced. So, it also relies on the area of an object, including the force it exerts upon the water. So, both these objects here are the same material, but they have different densities and obviously different areas. So let me move them real quick, and we can see how objects of different densities and different sizes interact with the water. So here we are. Let me just, oh, there we go. See, so the smaller one with higher density completely gone through that water. The bigger one doesn't even touch the bottom. So we can see here that this is how essentially boats float. And yeah, that's that's it. Thank you. Bye.